Thank you, Team Forget It. Good job. This is Team HAPTIC.
And we're just going through a few technical difficulties right now. All right. Hi, I'm Brian. Our team is Team HAPTIC, and we are researching assistive educational devices for children with visual impairments. So parabolas. These are quite simple graphs, but how would you learn them if you had a visual impairment? Even though the general shape is easy to graph, it can be difficult to determine the orientation, scale, and position of even simple graphs. Does the parabola open upward or downward? How many units is each tick mark? Is a parabola centered at the origin? There are many complex ideas which are difficult to display with only a raised picture. This is just one example of the many visual concepts which are difficult for children who are visually impaired to learn. This is the problem we hope to solve, improving the ways children with visual impairments learn visual concepts. To begin, we conducted a systematic literature review, examining haptic devices used in research and education in order to determine what qualities would be most important to include in our educational device. Every device we came across had some amount of tactile interaction. Visually impaired students understand spatial information primarily through tactile inputs. In addition, multimodality, providing information through multiple senses, has been shown to improve usability. What we cannot portray through just touch with limited space can be provided through another mode, such as audio. Finally, the device needs to be adaptable, so it can be easily integrated into current classrooms. After exploring our options, we formed a partnership with Tangible Haptics and obtained their hardware, an electrostatics touch screen overlaid above a Microsoft Surface Pro. Essentially, when a user touches the screen, the computer recognizes this and can send a charge to that location, producing a textured feeling. By programming these textures on different parts of the screen, we can depict visual concepts such as graphs and shapes. With hardware in hand, we proceeded to address our research questions, which Ryan here will talk about.
All right, so we have three research questions we'd like to answer. Our first research question is, can we create and develop an electrostatic device that's able to represent graphical information tactilely? Our second research question is, can the students use the device to gather information that they already learned? And then our third question is, can the students use the device to teach them learn new mathematical concepts from the device? So what we have three specific aims that correlate to the three research questions that we have. So our first specific aim, or specific aim one, is product development. So that's going to be the development of our device. So we actually already acquired the hardware from Tangible Haptics. So what we'll be working on is we'll be doing the software to be able to display the graphical information tactile. And then our second specific aim is our motor learning study. So we want to see if students are able to recognize mathematical concepts that they've already learned. So for us, we're going to be doing shapes, and we're going to have the shapes being displayed on our device and seeing if the students are able to recognize those shapes. And then our third specific aim is to see if students can use the device to learn new mathematical concepts. So for us, that's going to be functions. So we'll be plotting functions on our device, teaching the students how to use the device and about functions as well, and then having testing later on to see if learning has occurred. So right now, for specific aim one, product development, we currently have two modes that we need to work on: the shape input mode and the function input mode. So the shape input mode would be for specific aim two. So we need to be able to create the shapes on our electrostatic device and see if the students are able to recognize it. So right now, that's what we've been working on, and we're able to display basic shapes such as squares, circles, and triangles tactilely on our device. And I will show you that later if we have time at the end. And then for our function input mode, that would go with specific aim 3. So that's what we'll be teaching these students. And so basically for both of these kind of graphical information, they need to be converted tactilely onto our device. And the way that works is it converts the graphical information to voltage conversion, and that will be shown on the device. But before the students work on our device, we have RB approval for adult blind users to give their feedback on our device components. So after developing the core modes described in the slide before, the device will be ready for the motor learning study and the cognitive study. So that's specific game 2 and specific game 3. While these two studies are occurring, the product development team will be working on supplemental features. These features are going to include, the first one will be audio. So as what Brian mentioned before, multimodality is key. So we want to be able to provide more information to the students while they're learning. So with audio, that will help them learn a lot easier or better. And then the next feature we'd like to incorporate is being able to zoom in and zoom out. So that's really important for trying to find edges and things like that on our graphical information. And then the third feature is a bit more, it's going to require a bit more time, but we want to be able to connect the teacher's computer or laptop to all of the students' electrostatic devices, so that way when the instructor makes a change on their own computer, that change will be reflected upon all of the electrostatic devices, so that instructor can teach multiple students all at the same time. And then another feature that we'd like to incorporate is just making a really nice layout for our application, just so it's really user-friendly and really easy to use. And if you notice, I have two more modes on there, miscellaneous mode and lesson plan mode. So miscellaneous mode is for kind of like the math concepts that we haven't incorporated, but are relevant to the target group that we're targeting for, so that's 10 to 12-year-olds. So we want to be able to incorporate other concepts such as fractions for them to learn. And then the lesson plan mode is for the instructor. So if the instructor wants to create a lesson plan, the instructor will be able to create slides in the lesson plan mode and then use that for creating a lesson plan. And now I'll pass it off to Alexa, who will talk more about the cognitive study as well as the motor learning study.
Thank you. So our second specific game is targeted to assess perceptual motor learning. In order to continue on to specific game 2, inclusion criteria must be met by the students to move on to the motor learning portion. For the purposes of standardizing our study, we'll be working with students that are blind from birth or from the age of 3, and we'll also require that students have no prior learning disabilities and be able to recognize shapes. The subjects will also be required to do a baseline requirement. So this will require that students get a 70% or better on a set of standardized tasks before moving on to the motor portion. These tasks will include simple motor tasks to make sure that the students can actually use our device. So once students move on to the perceptual motor learning study, they'll undergo 3 main components of pre-test, a feedback component, and a post-test. First, the pre-test will be completed, and this will include 5 cycles of shape recognition. And a shape recognition cycle is essentially a loop of shapes in a randomized order. Here we'll document the subject's incorrect and correct answers, and this will allow us to see if the subjects are accurate in their responses, but also if they're consistent with their responses for a set of given shapes. Then they'll move on to the feedback component. So here subjects will again undergo 5 recognition cycles, but this time the administrator of the study, so one of us, will give them feedback on if their answer was right or wrong, and then also give them up to 3 tries to reach the right answer. The last portion of specific game 2 is the post-test. Here we'll just complete 1 cycle of shape recognition, and the results will then be recorded. So at the end of all this data, we'll be able to compare the pre- and post-test results, and this will allow us to conclude if A, students can immediately recognize shapes, and B, if students can quickly learn to recognize shapes. Alright, so specific game 3 is the cognitive study. In this learning study, we'll randomize the students into 2 different groups, so we'll have a control group and a treatment group. In the control group, students will use current classroom tools, while the treatment group uses the device. Both students in each group will take a pre-test, be given a lesson, and then take a post-test. And then after a break period of about 1 week, the students will return and take a retention test in order to see if true learning has occurred. And from this data, we'll analyze it using ANOVA statistical models, and this will be able to tell us if there's a significant difference between the control and treatment groups. We'll also utilize t-tests, so this will tell us if different variable factors such as gender, slight age differences, or pre-test competency play a role in a difference with the test and the groups. Finally, we'll analyze direct user feedback. So although this isn't quantitative feedback, this qualitative feedback is really essential to make sure that our device best caters for students with visual impairment. So throughout this process, we've achieved a number of accomplishments, and a few of them include our partnership with Tangible Haptics, obtaining IRB approval, the Fellows in Innovation and Creativity Grant. We also earned second prize for the University Libraries Award, and our Launch EMD campaign raised almost $6,000. For the freshmen that are just immersing yourself into the Gemstone team process, we have a few words of advice. So one, yes, you're gonna run into challenges, but if your team works as a whole unit, you'll be able to not just overcome them, but really surpass them. And also it's important to realize that your research is subject to change. So our team came in set on the idea that we are going to be utilizing a pin-based hardware device, but after doing a lot of research for our lit review, we found that this really wasn't the best method to go about. So we did a lot more in-depth research with electrostatics, and in the end we ended up making our partnership with Tangible Haptics. So the main message we learned from this experience was to not just make connections, but collaborate with other experts, and also seek out partnerships. In the future, some of our anticipated challenges are further publication submissions, and also subject recruitment for the learning portions of our study. Regarding team dynamics, it's important to set long and short-term goals, so this will keep you up to date with your deadlines, and also keep you in the realm of your overall timeline for research. And lastly, meet outside of your set meeting times, not just to get other work done, but really make friends, like become friends with each other, have fun, and have a good time doing research. Finally, we have many people to thank for helping us get this far. We'd like to thank Tangible Haptics for partnering with us. We'd like to thank the Gemstone program for this amazing opportunity, Robin Dassler, our Gemstone librarian, and our brilliant and Brazilian mentor, Dr. Marcio, for being with us since the beginning, and many others. So thank you very much. Any questions?
How do you plan on getting your group of subjects? It seems like you have a pretty specific group you want to test on. How do you plan on finding them?
So a few of us are on the learning sub-team, and each of us are responsible for contacting a different county in Maryland, including PG, Howard, and Anne Arundel, I believe. And those counties have special education departments, so we're hoping to contact them, in addition to the School of the Blind that's located in Baltimore.
Richard?
Yes, so I know you talked a lot about helping students with math. What other disciplines do you hope to apply to your research?
This research can really be applied a lot further. So initially we had this big overarching idea of maybe doing art, somehow being able to incorporate that. But our study mostly focuses on math, which can really be further, go into a lot of disciplines. So not just shape recognition, but graphs, and that's already it's hard to get all the math concepts. I mean, if you think about it, your calc class is only a few weeks, and it takes up a lot of time. So being able to incorporate that on graphical material is really where our research lies.
So there's obviously a spectrum of like visual impairment. So when you go to your phase, the learning phase, are you going to try and find groups of people with consistent, I guess, levels of visual impairment? Because there's such a threshold for being legally blind to moving from seeing straight shapes to being completely blind. So are you going to be like ensuring you have a consistent level between each group? And
Right, so to standardize our study, I think I said earlier, was we're seeking students who have been blind since birth or from the age of 3. I hold it on.
In the back, in the burgundy shirt? Yeah, you. Sorry. No. Middle.
How did you choose 1 week in the retention period?
That was derived from previous lit review. Yeah, see.
What's that?
Yeah, development has been working on. So we're able to display basic shapes as what I said before. So this is a circle. I don't know if this is messed around. So basically, if you can feel kind of like the friction when you're on the circle, and then when you're outside, you don't feel the friction. And then we can change to other shapes as well, like the square and the triangle.
And we understand this is not very exciting for you, because clearly you can see that this is a circle, and not everyone could field the device, because we just don't have enough time to like carry it around to people. But really it creates a texture, so the texture right now, it feels like graphite. And we were hoping that we could get Dr. Cole to come up and, yeah, shock. He has not held the device, so hopefully, I mean, he already knows that it's a circle, but he's excited that it is actually a circle.
Blindfold.
Yeah.
Maybe a little.
Oh, yeah. All right, we're going to change the shape so you don't know what it is. Now take a try.
Oh, it's
To find it, yeah. Go on.
It's straight edges.
You're trying.
We have time for one more question. In the back.
So, our common statement on the post-test, you're going to get 3 chances to get educated, right?
That's not the post-test, that's the feedback component. So that's kind of to allow students to get a response on whether they're right or wrong and give them up to 3 tests to get the correct answer. But that's not the results being analyzed with the pre and post-test, that's the middle component.